Okay, if you missed the first video, you're going to need these 4 formulas, but you should have probably already gotten them in that first video. Now let's finish the examples. Alright, in this one we're going to take the region that we had before and we're going to revolve it around the x-axis. Now I'm going to pause this to draw my picture. You're going to notice in the next 3 pages where I do the other 3 examples that I'm going to leave some room accordingly. In this first one, when I draw my graph, and you knew what it looked like from the last example, since I'm going to be revolving this one around the x-axis, I'm going to want to leave some extra room. I'm totally going to redraw that. So I'm going to leave extra room to revolve it around the x-axis. You might want to do the same. I'm going to pause just to not suck up the time with me drawing the picture. Okay, so now I've left room so that I can reflect it about the x-axis. And this is the matching point down at the bottom. Try to make it look a little 3D if you want. And now I need to decide on a method. You want to make sure you realize, because you're going around a horizontal axis of revolution, that there's a certain variable that we use, as far as our function and our integrals and everything. But I mean, just think of this as the radius of the circle if you cut into this shape. So the radius of this circle is a vertical line. Vertical lines are y equals. So in this case, it's going to be y equals 2x squared, and that is your radius. So we're going to go volume is pi times radius squared from x bound to x bound. So that's going to be 0 to 2. I'm going to use the calculator to integrate this. Again, if you want, put in the calculator for x to the 4th. Might be a little quicker. And hit play once you get the answer. Okay, and you can check your answer. The answer is 128/5 pi. Always make sure you turn it into an improper fraction. Okay, here's the next one. Now we're revolving around the line y equals 8, so I'm going to pause and draw my picture. Again, make sure you leave room to revolve around the proper line based on what the shape looks like. Okay, so to leave room to revolve around the line y equals 8, I'm showing you here that I kind of drew in a dotted line. I'm going to revolve around there. So you see this is actually going to go up as high as 16. And I'm going to draw the best sort of mirror image I can up here. And then try to make it look a little bit 3D. It looks a lot better when I do it on the board. It's cool. Okay, so what does that kind of look like? Like a cylinder with sort of a bowl hollowed out of it. Alright, so now what are we going to need? Always draw the radius or the radii, if there are 2 of them, from the axis of revolution to the shaded part. Now since you're hollowing out a piece in the middle here, we're going to have an inside radius and an outside radius. So we're going to draw our inside radius. I'm just going to do a few of them. Right, that's how you're going to get your inside radius. And let's just start by writing that function. Since you know it's an inside radius, it's going to be lowercase r. Now since these are vertical lines, then these are all y equals some function of x. Okay? So I'm going to do little r of x. Because again, a y always equals a function of x. Now this one's different than what you're used to. You know that y equals 2x squared, right? But y equals 2x squared gives you the length of this line. Well, we don't want this line, and this line, and this line. I'm trying to give you a hint. We want this one, and this one, and this one. So if I don't want the red, but I want the green, and this is what's actually measured in red, that y distance, then think about how we would get the green. Now here's, again, your hint. I kind of had written over. This is the line y equals 8. Is that giving you a hint? from here to here would be, alright, hopefully, maybe you got it. This is going to be 8 minus 2x squared. Your little r of x is going to be 8 minus 2x squared. Because again, the 2x squared is this part. But we don't want this part. We want the part that starts here and goes up. So that's 8 minus 2x squared. Alright, lastly, for this picture, the outer radius, that's a little bit easier, because look at your outer radius. To the outside of the shaded part, it's always the same, right? To the outside of the shaded part, it's always 8. Y equals 8. Alright, so now we can set up our integral. And if it looks like it's going to come out rational, then we can just let the calculator do it. Pi, and where everything's in terms of x, so I'm going to integrate from 0 to 2 of the outside radius squared minus the inside radius squared. And I don't even think I'm going to work any of that out. I'm just going to put it all in the calculator as is and let the calculator give me my answer. Okay, if you didn't already try it, make sure you pause this. Don't just take my answer. But I'm done, and I got 896 fifteenths, and then don't forget to put the pi back on. Alright, next. Okay, to revolve around the line x equals 2, make sure you leave some room to go around that line and to have your mirror image on the other side. I'm going to pause and draw mine. Okay, so I have left myself some room on the other side of 2. Let me draw this in as an axis. So I'm revolving around this line, the line x equals 2. So x equals 2 is kind of going to be my mirror. And I'm going to have this cone with like some sort of curvy sides, right? That's what I have. Okay, so again, because my axis of revolution is shifted, it's not just the x or just the y axis anymore. We're going to have to be a little careful when we do a radius. But at least with this radius, like there's no hole in here. Here's my radius, here's my radius, here's my radius. So I don't have to think of a bunch of, you know, this is I only have one radius, not an inner and an outer. Okay, so this is a horizontal line, right? So this is x equals something. Now we figured out a few problems ago that x equals the square root of y over 2, right? But we can't change the meaning of what that is just because we want where this green line is. X equals anything actually gives you the distance between the y-axis and this curve. So all these red lines that I'm drawing are x equals the square root of y over 2. So if you instead want these lines, think about what we did in the last problem, can you come up with what our function is, what our x equals? Our x equals our function of y. And what is our function of y? Well, it is, okay, the whole thing across is 2. So it's 2 minus the square root of y over 2. That's your radius. Alright, so now it just remains to find the volume. Alright, so volume equals pi r squared so there's our radius, let's square it. And now we need y bounds. We're going from 0 to 8 for our y bounds. Again, it's because everything's in terms of y. Now let's think about this one. You could go ahead and jump into the calculator if you want. But if you have an irrational answer, I do not want the calculator's answer. And if you FOIL this, we're going to get what? 4 minus 2 of those square roots minus another 2 of those square roots, so minus 4 square root of y over 2 and then plus the last term squared. Now, if you think about what kind of definite or indefinite integral this is going to give you, this gives you 4y. This gives you y squared over 4. But this is a y raised to the 1/2. Well, y raised to the 1/2 when you integrate it is y raised to the 3/2 times 2/3. Well, when you raise any number to the 3/2, really you're potentially getting a square root, so this is probably going to give us an irrational answer. So we are going to work this one out. So this is pi times 4y minus, now I'm going to think of this as 4 over the square root of 2, and then I'm going to integrate the square root of y. So the integral of y to the 1/2 is y to the 3/2 times 2/3. And then the last one is a 1/2 y squared over 2, or y squared, oh, that didn't look very nice, y squared over 4. And this is evaluated from 0 to 8. Times 4y squared over 2. So, oh, I already integrated. Sorry, I gotta plug in the 8. Okay, 4 times 8. And then minus, how do I want to do this? We'll clean it up later. 8 over 3 times the square root of 2. And then if we're plugging in 8 to the 3/2, make sure you don't go to a calculator for this. 8 to the 3/2, yes, you can do 8 cubed and then square root it, or you could do the square root of 8 cubed. Now the square root of 8 is 2 times the square root of 2. 2 times the square root of 2 cubed. Oh, I guess another way I could have thought of this was 8 times the square root of 8. And then, and again, 2 cubed is 8, so the square root of 8 is 2 times the square root of 2, so 16 times the square root of 2. Huh. Well, maybe we could have gone to a calculator after all. Alright. Then we have y squared over 4, which is 64 over 4, which is 16. And what I did not expect to happen was that these square roots of 2's cancel out. How about that? So I think I might want to finish without a calculator just to be stubborn. So I now have 32 plus 16, which is 48, which is 48. This is all going to be times pi later. And then 8 times 16 is 4 times 16, 64, so 128 thirds, and 48 is 144 thirds, and 144 minus 128 is 2016. Yes. So 16 thirds pi. I might want to put an arrow here because I kind of butchered this. None of this stuff is equal, but this should be the final answer. I'm going to check mine on a calculator. And if this is wrong, then you guys should check it, and maybe I'll throw Sophia a question in if this is wrong, or come in with it done correctly tomorrow. I have 2 more examples, but I'm probably not going to get those up until even later than this one. So this is it for this video. Stay tuned for the next one.